So in my last video I showed off some really cool bit masking, but something else I want to show off that's probably more important when it comes to game development is if you're working on a really big project, you're going to want to eventually be able to do editor scripting. You might have defined some sort of custom class, custom data structure that you need to be able to fill out inside of the inspector. And I'm going to be showing off now how I made this Bitmask property jar. So I have this damage Bitmask, which is just an integer I explained in my last video. If I enable and disable these Boolean flags, it turns on those bits inside the integer and it tells me the output of the number. And if we open up and look at this script, it is just an integer. And what I do is I'm telling it to draw this damage type. So how does this work? So the first thing you have to do is you need to define an attribute. So inside of my damage struct, where I have my damage defined, I've got this damage type attribute. And you have to call this a property attribute so that you could put it in inline fields right here, kind of like a serialized field is a property attribute. Then after you define a attribute, you actually need to go into your scripts. You need to make or find a folder called editor, and this is really important. I'll explain later. And then you make a script specifically just for the property jar. Now the reason you have to do this in editor is because we have to use a library called Unity Editor. This gives us access to things like the property jar parent class, the GUI content, things like that, and those aren't available when you build your game. When you build your game, it doesn't include these libraries, so you're going to get build errors. By putting this script inside of a folder called editor, that's basically telling Unity to not include those in the build. So it's not going to build those files. Those only run inside the Unity engine editor. So let's go back into this and see what I'm doing. So because this is for a Bitmask, I store a whole bunch of Boolean data for each individual bit, whether it's true or false, whether it's 1 or 0. And I'll explain what this does, but the most important function is this onGUI function. What this is basically going to do is you're overriding the property jars onGUI. The Unity engine itself is going to call onGUI whenever a window update happens. So when you control Z, it's going to update. It's going to call this function. When you change the size of the screen, it's going to call this. When you exit play and you begin play, it's going to call these. So this is where you basically put all of your logic. Now, something else I forgot to explain is this custom property jar attribute. If I got rid of this, let me show you what happens if I get rid of this. It no longer applies this to the damage type attribute that we defined. Now, damage type attribute is just an empty thing, but we use it to tell your property jar to just draw on this data. Now, if we go to it, it's gonna try to draw that on every single integer, or it's also just not even gonna know what to draw it on. So that's why we use this attribute, custom property jar type of, and then your attribute, so that we know what to draw it on. If you want to do other stuff, you could say you don't need an attribute for everything. You could define it as just everything that is an int gets drawn like this, or you might have a custom class that you could put in there. But for this, I have my own attribute for the Bitmask. The next thing that I want to show is what this does. So this is another override function that is from the parent property jar that the Unity editor calls. And this actually tells the Unity editor just how tall the property inside the property jar window is. So if we change this to something like, let me just say return like 16F. Oops. Let's just return 16F. And let's see what happens over here in our property window. You see, it will get really small, but it's still drawing those, but not enough space. So I am telling the Unity editor that I want this much space for each property that draws like this. Alright, but going on to the actual stuff, your onGUI function, you should always start it with editorGUI.begin property and editorGUI.end property, because what this does is it lets the Unity engine remember different state values. So if you control Z, it'll actually remember everything that happens in here, and it'll undo all the stuff. Yes. So I'm going to comment all this out so we can see what this does and just what this does. So I can also comment this out. So for all intents and purposes, I'm also going to comment this out. For all intents and purposes, all that's happening is I'm drawing these two things. This is what's called a label field. You give it a rect for its position, and then you give it like the name or content. You have to give it a string for the name, and then you give it the content. So if I go into here, you see I have damage and Bitmask. You see Bitmask. Damage is actually the name of the property, and the property is a serialized property that's either this or it's this. So as you see, one is damage, one is resistant, and then after that, within the label field, I say to draw the integer or whatever, or string or whatever it is. So it is always a string, so you have to call toString if you're getting an integer. So I get that integer, it's 0, and then I also get a string of those. I'll explain that in another one. So, but what happens if we enable this stuff down here? Well, these are all GUI.toggles, and this is used for drawing booleans. So if I disable, or if I enable them again, I should say, we've got a whole bunch of these. And what I'm basically doing here is I've already defined these booleans for the bits. I'm setting those booleans equal to the output of this toggle. So remember, this onGUI is going to be called whenever a window update happens, and this toggle is going to contain whether it's true or false. So we're setting physical equal to that. Physical is one of our damage types. We also have to tell the toggle what state it's in. So the physical toggle is in physical, but if that was true before, it doesn't matter. You'll see why this is so important in a moment. So all these booleans, even if you don't tell them that they're true, they default initialize to false. So right now, these are all like that, but if I play the game, you see it went back to 0, because again, we're going through all of this, these are false, and then it says, oh cool, now all of these are false. That's a problem. That's actually why I'm using this setBools property, this setBools function. What this is going to do is it's going to go into our property, the actual like Bitmask number, and it's going to turn these booleans on or off based on if that bit is true. So if I could go down here, setBools, yeah, all it does is it say if the damage utility contains the type of Bitmask. So if the Bitmask contains this damage type, set that boolean to true. And what that'll help us do is it will basically, if I remember to do it down here, you need to make sure to set the property value back to actually change it. If you don't set the property value, it won't change. It'll just stay the same forever. So now if I change these, play, it will remember, because it's going to go back and set those booleans to what they were supposed to be, and everything works. And actually, I think that's everything, really. I do have this string called Bitmask as binary, and what this is going to do is it's just creating a string of 1s and 0s for if each bit is enabled or disabled. But for the most part, that's just how property drawers work in Unity. It's very easy, very useful, so you should try to add them whenever you can in Unity. Thanks for watching.